Hello and welcome again in this video number 9, which I suppose is going to be the last video for this series on chemical reactions that I have started for the 7th grade students of GCSE. And this was chemical reactions was chapter number 8 from your textbook. Okay, so perhaps this is the last video, that is video number 9. So let us get started. Now this is the topic that we are going to discuss in this today's session, that is reaction of metals with water. Okay, so let us get started with this reaction of metals with water. Now metals, they combine with oxygen, and you know that corresponding metal oxide is formed. Okay, this you know very well, and this metal oxide layer will be formed over that metal. Okay, and that metal will get covered by that layer of metal oxide. Okay, this is normally what happens when any metal combines with oxygen. Now, in the same way, when some metal is reacting with water, what happens is, uh, first of all, you know, when you want to react any metal with water, first you ensure that the metal oxide layer, if at all it is, suppose the metal is kept in open and it has been reacted with oxygen, so metal oxide layer will be formed over that metal. So that metal oxide layer has to be removed. Okay, somehow you have to remove that metal oxide layer, and then you have to think of reacting that metal with the water. Okay, so whenever you try to react any metal with water, first you ensure that the metal oxide layer, if at all, if there is no metal oxide layer formed, then no problem. But if metal oxide layer is formed, then you have to remove that metal oxide layer somehow, and then you have to treat that metal with water. Okay, so first you have to first using some sandpaper or something like that, you can remove that metal oxide layer. Okay, now metals if do not react with cold water, possibly may react with hot water. So sometimes, you know, some metals, they do not react with cold water. Okay, so cold water doesn't make any changes to the metal, but then maybe hot water, if you put the metal, or if you treat the metal with hot water, maybe reaction will take place. Okay, so that will depend. So let us see how to study this metal reaction with water. Okay, so let us start first with sodium and potassium. Now you know that sodium and potassium, these are very highly they are highly reactive. Okay, reactivity series, and in reactivity series they occupy the highest position. So they are very highly reactive. So sodium and potassium are highly reactive, and because they are highly reactive, they are highly reactive with water also. Okay, they react very vigorously. Okay, when this metal like sodium and potassium, they come in contact with water, they react very vigorously. Okay, and they need to be preserved in oil. Now because these metals like sodium and potassium, they react very vigorously with water, that is why they are preserved in oil. Okay, because in the air, you know, water vapor is present. So if it is kept open, if these metals are kept open, then the moisture of the air, you know, moisture is nothing but water drops. Okay, so that water drops will react with this metal, and the reaction will take place. Okay, so to avoid that reaction of sodium and potassium with the water vapor in the air, okay, we always keep these metals in oil or in kerosene, because oil or kerosene, they will prevent the metal from coming in contact with the moisture in the air. Okay, to avoid contact with water vapors in the air. Okay, so this is why they are kept in oil. They need to be preserved in oil or kerosene to avoid contact with water vapor. Sodium and potassium, I have written the symbol over here, Na and K. Okay, sodium and potassium react with water, and the word reaction is sodium and potassium will react with water to give you respective hydroxide. So if it is a sodium metal that you are reacting with water, you will get sodium hydroxide. If potassium metal you are reacting with water, you will get potassium hydroxide. So respective hydroxide will be formed, and along with this there will be hydrogen gas which will be produced. And because of this hydrogen gas, there is a kind of explosion taking place. Okay, so hydrogen gas will, will come out with a slight explosion. Okay, low intensity explosion, but there will be a little explosion of hydrogen gas, right? Now, if you want to write a chemical equation of this, is not expected from 7th grade students, but I have written it for you because now we'll be coming to the 8th grade. So sodium, for sodium, I've written Na. Now there is a 2 written in front of Na. That means 2 atoms of sodium are reacting. Then plus 2 H2O means H2O is water molecule. And before that, I have placed a 2. So 2 molecules of H2O is taken. So 2 molecules of H2O and 2 atoms of sodium, they will react with each other to give you NaOH, and in front of NaOH I have written 2. So this is the meaning of this is 2 molecules of NaOH. NaOH means sodium hydroxide. Okay, see, this is sodium hydroxide. I told you metal reacts with water to give you corresponding hydroxide. So sodium will react with water to give you sodium hydroxide. So I have written 2 NaOH plus H2. H2 is the formula for hydrogen gas. Okay, so plus H2. And I have put a arrow mark in the upward direction indicating that this hydrogen is a gas. Okay, whenever in the product you get a gas formation, you have to put an arrow mark in the upward direction. Okay, and suppose you want to write the similar reaction for potassium, then you will write 2K, that is 2 atoms of potassium, plus 2H2O, that is 2 molecules of water, will give you 2KOH. KOH is potassium hydroxide, and 2KOH means 2 molecules of potassium hydroxide, plus H2, that is hydrogen gas, and you can see that arrow mark is there. Okay, so these are the exact chemical reactions that can be written for this reaction of sodium and potassium with water. So basically, sodium hydroxide or potassium hydroxide is formed, and along with that, hydrogen gas is also produced. This is that reaction of sodium and potassium with water. Now let us go and try to see how other metals react with water. So let us start studying calcium and magnesium, and let us see calcium, magnesium, they react. But this calcium and magnesium, they are slightly less reactive compared to sodium and potassium. So they will not be, the reaction will not be very vigorous with water. Okay, so calcium and magnesium react less vigorously. Sodium and potassium were reacting very vigorously. Okay, because sodium and potassium are highly reactive, but calcium and magnesium are less reactive compared to sodium and potassium, and therefore the reaction with water is less vigorous. Okay, it's not very vigorous. And in general, you can write magnesium. Now I have written just mag. Okay, so you have to understand it is magnesium word reaction. Okay, so magnesium plus water. Okay, now for magnesium, as I told you, I mentioned over here that sometimes cold water doesn't react with some metals. Okay, so you have to take hot water. So for magnesium, cold water doesn't react with magnesium. Even hot water doesn't make any difference. But if you boil the water and convert it into steam, then that steam reacts with magnesium, giving you magnesium oxide. Okay, it will give you magnesium oxide and hydrogen gas. And the reaction can be, chemical reaction can be written this way: 2 Mg, Mg. Mg means at 1 atom of magnesium plus H2O means 1 molecule of water. So 1 atom of magnesium reacts with 1 molecule of water to give you MgO, means magnesium oxide. So 1 molecule of magnesium oxide and hydrogen gas. 1 molecule of hydrogen gas is also produced. So this is a reaction for magnesium with water. Same way, calcium with water can be written as Ca, symbol of calcium, plus 2 molecules of water. Here you need 2 molecules of water, and here you don't have to convert it into steam. Okay, even cold water will react with calcium. So calcium reacts with water, no need of heating it or converting into steam. So ordinary cold water will do. Will give you CaOH twice, that is calcium hydroxide plus hydrogen gas. Okay, so these are the reactions. So word reactions, if they ask you for magnesium and calcium with water, so you have to write magnesium plus water will give you magnesium oxide plus hydrogen gas. and calcium plus water will give you calcium hydroxide plus hydrogen gas. This is that reaction. Okay. Now let us try to answer some questions connected to this particular topic. So first let us see this question number 1. Now what is this question number 1 saying is write the word equation for the reaction between sodium and water. So I've already mentioned here sodium and water. This is that reaction you have to write. Okay. But you have to write word equation. So answer will be sodium plus water. You have to write the word. Okay. Sodium plus water giving you sodium hydroxide plus hydrogen. Okay. So this is known as word equation. Question number 2 is what safety precaution must be taken when these reaction takes place? So whenever sodium and water are reacting, I told you hydrogen is produced and there's a kind of small explosion taking place. So you have to take some precaution. Okay, so what safety measure you have to take during this reaction is you must wear safety glass. Okay, metal, that is sodium metal, must be held with the tongs. So this is the second precaution. And third is it must be held with tongs and not hands. And third is only small quantity of metal must be taken. Okay, so don't take a big piece of sodium and try to make it react with water. Okay, take a very small piece of sodium so that explosion will be small. If you take a bigger piece or a large quantity of sodium metal and if you react with water, then the explosion due to the hydrogen form will be very large. Okay. Now question number 3 is explain why metals are stored under oil. Why these metals are stored under oil. So these means sodium and potassium is talking about. So answer for that is these metals, that is sodium and potassium, are stored under oil or inside oil because they are highly reactive. We know sodium and potassium are very highly reactive and they react with the moisture in the air. So in the air there is water vapor. So the water vapor will react with the sodium and potassium to give hydrogen. Okay, and you know the product of this reaction is hydrogen gas, which explodes. So depending upon how much metal you have taken, if you have taken small quantity of metal, the explosion will be very small. But if you take a large quantity of metal, the explosion will be more. Okay. So these were the 3 questions connected to this topic, reactions of metal with water, and we studied only this sodium and potassium and calcium and magnesium so far. Fine. Chalo. Now let us try to study in the next slide, that is calcium reaction with water. What is the reaction of calcium with water? We know calcium will react with water. Okay, but the reaction is not that vigorous, and for calcium you don't have to convert the water into steam. Okay, so first let me show you this slide. Can you see this slide? In this slide, the reaction of the calcium with water, okay, is shown over. So in a beaker, basically you have to take some small quantity of calcium in the beaker, and the beaker already contains some water. Okay, on that calcium you keep a inverted funnel. Okay, and the water and the calcium will react, and reaction will take place, and calcium hydroxide will be formed. Along with calcium hydroxide, there will also be hydrogen formation, hydrogen gas formation. So this hydrogen gas formation, when the reaction takes place, will be coming out from this funnel. Okay, and it can be collected into this test tube. So there is a test tube which is inverted over the funnel. Okay, so hydrogen gas coming out from this funnel, okay, gets converted, gets collected by downward displacement because hydrogen is lighter than air. So hydrogen will go and occupy the space above in the test tube over here. So here you will get hydrogen gas, and the air will be displaced in the downward direction. Okay, so basically hydrogen that is formed in this reaction is collected in this test tube, and once you want to use this hydrogen in the test tube, you just remove this test tube from this, and you can place your thumb or a stopper on the test tube. So you will get the hydrogen gas which is trapped in the test tube. Okay, so this is how the entire process takes place. Now this is written over here, everything. Now let us try to answer this question numbers 4, 5, 6 and 7 connected to this particular investigation. Okay, so question number 4 is over here, and it says that which is the gas that is given off, how would you test for it? Okay, so in this reaction, as I told you, in this investigation, there's a reaction taking place between calcium and water. So first we should be able to write the word equation. So word equation will be calcium plus water forming calcium hydroxide plus hydrogen gas. So from this word equation itself, it is very clear that the answer to question number 4 is, what is the gas that is given off? The answer will be hydrogen is the gas that is given off, because calcium hydroxide is not a gas. Okay, calcium hydroxide is a solid. So the gas that is given out in this reaction is hydrogen gas. The answer will be hydrogen gas for question number 4. Now, second part of the question is how we are going to test for it. So for testing the hydrogen gas, the formation of hydrogen gas or the existence of hydrogen gas, what you have to do is you have to take a splint, a stick, okay, which is already burning, okay, and you can always place in near the mouth of the test tube which is containing hydrogen. Okay, so what will happen, that hydrogen will burn or it will explode with a pop sound. Okay, so when that happens, it is very clear that the gas that you are testing is hydrogen. So this is the test for hydrogen. Whenever you want to test whether a hydrogen gas is formed or not, you have to collect the gas first and you have to do this procedure. Okay, so a burning splinter, okay, will burn with a pop sound, okay, or it will explode with a pop sound. Okay, if that happens, that means it was hydrogen gas. If that doesn't happen, that means the gas was something else, right? Now question number 5 connected to the same investigation is, how could you tell if calcium or magnesium is more reactive? Okay, now you know that calcium also reacts with water, magnesium also reacts with water. Now, and both, you know, calcium or magnesium, whatever it is, when it reacts with water, calcium hydroxide will be formed if calcium is taken, and magnesium hydroxide will be formed if magnesium is taken. Okay, actually in the case of magnesium, it is magnesium oxide, not magnesium hydroxide. Okay, but the product formed is hydrogen, which is common in both. Now, which is more reactive or which is vigorously reacting? So suppose the hydrogen gas produces more, okay, in one particular case, then that particular case is indicating that the metal used is more reactive. So suppose in the experiment you are taking calcium and making react it with water, and the hydrogen gas you are getting more. That means hydrogen is that means calcium is more reactive. And if you are getting more hydrogen produced when you are reacting the water with magnesium, then you can say that magnesium is more reactive. So whichever experiment is giving you more amount of hydrogen, that will be more reactive. So answer for the 5th question is, the more volume of hydrogen gas produced will tell you or will be more reactive. So if calcium gives you more hydrogen gas, then calcium is more reactive. If magnesium gives you more hydrogen gas, more volume of hydrogen gas, then magnesium is more reactive. Whichever is giving more volume of hydrogen will be more reactive. That is the answer. Question number 6 is, what factors should you take into account to what is this? I'm going to read it properly. One second. Question number 8, right? Okay, what factors would you take into account to make this a fair test? Okay, so for this test to be fair, you know, what you will do is, the answer is, for a fair test, you will take equal amount of magnesium and calcium. So see, you have to check which one is more reactive, calcium or magnesium. Okay, so the amount of both the metals taken should be same. You cannot do that you cannot think of taking more magnesium than calcium or more calcium than magnesium. No, both magnesium and calcium, both the metals should be taken in same quantity. Moreover, both should be added to the same equal amount of water. Okay, water also should be in equal amount. Okay, and the temperature should also be same. Okay, so temperature should also be same for both the reactions. Okay, after keeping all these variables constant, suppose you get more amount of hydrogen in one particular case, then that will be more reactive. Okay, and where you get less amount of hydrogen produced, that will be less reactive. So this is what you have to say for this answer. So for fair test, you have to take same amount of the metal and the same amount of the water, and the temperature should also be same. The last question being question number 7. Write the word equation for the reaction between sodium and water. So question number 7 is write the word equation for the reaction between calcium and water. It's not sodium and water, calcium and water. So of course your answer will be calcium, okay, plus water, giving you calcium hydroxide plus hydrogen gas. This is the word equation that I have already written here. Okay. So these are the first 7 questions related to this reaction of metals with water. Now let us see how magnesium reacts with water. So in this slide you can see magnesium reacting with steam. Okay, so what you have to do is in this test tube you can see this investigation. In this test tube, they have taken some magnesium over here. This is magnesium metal, okay, Mg, and it's in the powder form, okay, and it is heated, right? And here, can you see this portion? This is wet cotton or wool. Okay, so you have to take wet cotton or wet wool, and when you heat it, what happens? This wet cotton or wet wool will convert into vapor, and this vapor will come in contact with this magnesium. Okay, so steam is basically reacting with magnesium, right? And to create steam, to get the steam, this is what you have to do. You have to keep a wet cotton or wool soaked in water. You have to keep it over here in the test tube, right? And then you have to heat the test tube, right? Now the reaction will take place between magnesium and water, and in the reaction magnesium oxide will be formed, okay, and hydrogen gas will also be produced. So magnesium oxide being in a powder form, okay, it will just remain here only, and hydrogen gas, which is the second product, that will escape from this tube out over here. Okay, it will escape from this tube. Okay, the tube is fixed into a stopper. Now this hydrogen gas can be tested with a burning splinter, and if there is a pop sound, that indicates that the gas being collected is nothing but hydrogen gas. So this is that investigation, right? So this is all written over here in this investigation, what happens. Now related to this, you have question number 8, 9 and 10, right? So let us one by one complete this. So question number 8, it says that explain using particle theory why the reaction between the steam and the magnesium is more vigorous than between the water and magnesium. So using the particle theory, you have to explain that the reaction between ordinary water, that is cold water, and magnesium is not taking place. It doesn't take the reaction doesn't take place between magnesium and cold water, but between steam and magnesium there is always a reaction taking place. So what is the reason? So the answer is steam has more heat energy compared to the water vapor, and hence the magnesium reacts with the steam, and it gives you the products. Okay, so steam is obviously having more heat energy, okay, compared to ordinary cold water, okay, and therefore the steam will react with magnesium, okay, readily, vigorously. Okay, so this is the answer for question number 8. Question number 9 says that name three metals that do not react with water. So the three metals that do not react with water can be gold, silver, as well as copper. There are many more. One aluminium, zinc, iron. Of course, zinc, iron, they react with water. But gold, silver, and copper, these are the three metals which hardly react with water. Okay. And last question is question number 10. If an element is said to be inert, okay, what does it mean? So when an element is inert, the meaning of this is it is chemically inert, or you can say it is inactive, okay, or you can say non-reactive. Okay. So these are all the alternate names of one and the same thing. So whether you call it as an inert element, or you call it inactive, or you call it non-reactive, one and the same. Okay. So this was the answer to question number 10. And now we are going to the next slide, and this slide is the last part of your this video, and these are the exam style questions. Okay, so let us start from question number 8.1. Okay, now here I don't think I have given the questions, but questions you can take from your textbook. You can see from your textbook. So for you, what I can do is I can read out the question, okay, and the answers only I have written in this particular notes. Okay, so question number 8.1, I'll read out for you, and it is already in the textbook. Okay, so question number 8.1, first we are going to discuss this. So question number 8.1 says that match these words or phrases to the description of A, B, C, D, and E. Okay, so they have given you some descriptions. Okay, A, B, C, D, and E. So you have to match the phrases given with A, B, C, D, and E. Right, and the phrases are given over here, so that you can take it, you can read from your textbook. And the words given here, each word or the phrases are also given. So the phrases given are burning, decreases, exothermic, increase, exothermic, evaporation, etc., etc. Okay, so yeah, this is like matching. So statement number A is an example of chemical reaction where thermal energy is given out to the surrounding. Now this statement that I read just now, A, is nothing but a statement for a exothermic reaction. See, in exothermic reaction, thermal energy is given out to the surrounding, isn't it? So the answer for the A should be exothermic reaction, okay? And okay, it should be exothermic reaction. So I have written for A, burning. Okay, there are other also statements, okay, in this. I mean, not the statements. Even this is there. Burning of, sorry, burning is there, okay, and magnesium reacting with dilute hydrochloric acid is also there, okay. So these two are also nothing but exothermic reaction. So answer can be exothermic reaction, which I have written for E also, but for A also exothermic reaction you can write. Along with exothermic reaction, you can write burning also, and magnesium reacting with magnesium ribbon placed with hydrochloric acid. This also you can write, okay. And statement number B is an example of an endothermic reaction. So for endothermic reaction, in this phrases, you can write sodium hydrogen carbonate added to citric acid. Okay. So B statement, which is an example of endothermic reaction. Okay. So that should be, for that the phrase should be chosen this one, sodium hydrogen carbonate plus citric acid. Okay, because this is an endothermic reaction. Then C is the temperature in an endothermic reaction. Now what happens to the temperature in the endothermic reaction? So the temperature decreases, isn't it? So yeah, for C, the answer will be decreases, right? The temperature of the surrounding decreases, right? because the heat energy is taken in the endothermic reaction. Then the D is an example of an endothermic process. So melting of ice is nothing but a no, melting of ice is not an endothermic process. Okay, so D answer is not melting of ice, it should be something else. Melting of ice, is uh, yeah, melting of ice is endothermic here because it is taking in the heat, right? That is correct. Melting of ice is endothermic reaction because the heat energy is taken in, right? Let me correct this. Yeah. So melting of ice is obviously a endothermic reaction. Okay, melting out because heat energy is taken in, not given out. So for D, you will have to write melting of ice. Now this melting of ice I was taken from the phrases. Okay, and E is the statement is the type of reaction between calcium and water. Now calcium and water they react, and in this reaction, what is happening? uh, in this reaction, the heat is given out, isn't it? So it is an exothermic reaction, right? So you have to write exothermic for this heat, right? So that was question number 8.1. A, B, C, D, we have A, B, C, D, E, we have written the phrases, okay? Now 8.2, let us come to 8.2. 8.2 says that burning a chemical reaction where thermal energy is given out to the surrounding. Marcus has four fuels to investigate. Okay, and find out which gives out more thermal energy to the surrounding. He uses the apparatus like this. So here also you can refer to the textbook, and the answer for A is the question for A is which variable will Marcus change? Okay, so the Marcus is going to take a variable which is changing. That variable will be fuel. So answer for A is fuel. Okay. Now B is name two variables Marcus must keep the same. So in this investigation, what are the variables that he has to keep constant? So that is the quantity of the fuel and water in the beaker. He should keep constant, and the time for which he is heating that particular thing, that should also be kept constant. So these are the constant variables, right? Fuel is the variable, changing variable, and the constant variable will be the amount of fuel and water and the amount and the time for which they are heating. Okay. C is explain what he must do in order to be able to identify which fuel give out more thermal energy to the surrounding. Now for this, he will have to see like the answer should be check the rise in temperature, and in which case the rise in temperature is more. If the rise in temperature is more, that means that particular reaction is giving more thermal energy. Okay, so more thermal energy will be given out. Okay, then the rise in temperature will be more, and if less thermal energy is given out, then the rise in temperature will be less. So the change in temperature or the rise in temperature is something that is going to indicate what is happening. D question is name one safety precaution he should take while carrying out this investigation. Now, what is the safety precaution that he has to take? He has to wear safety glasses and he has to wear gloves in his hands. Okay, so this was answer to 8.2. 8.3 is question says copy and complete the following word equation. So the word equation that you have to complete is sodium hydroxide plus dash. Now this answer I have already written. No, first one is A. Carbon plus something is equal to carbon dioxide. So that something will be oxygen. Carbon plus oxygen will give you carbon dioxide. This is word equation. B is sodium hydroxide plus something will give you sodium chloride plus hydrogen. So sodium hydroxide when reacted with dilute hydrochloric acid. So you have to write here hydrochloric acid. I should not write the formula. I should write the name. Okay. So let me write hydrochloric acid. Okay. Sodium hydroxide plus hydrochloric acid. Okay, dilute hydrochloric acid. This will give you sodium chloride plus hydrogen. C is something plus oxygen will give you magnesium oxide. So of course magnesium plus oxygen will give you magnesium oxide. D is potassium plus water will give you something plus something. Now potassium when reacts with water, you know it forms potassium hydroxide as well as hydrogen. So you have to write your potassium hydroxide and hydrogen. Okay. So that was 8.3 and 8.4. 8.4. The question is, okay, here again, you know, in the textbook, you will have to refer to your textbook for this. Okay. So a huge chart is given to you, and uh, is mentioning in this 8.4 that there are two people, Zara and Arun. They are carrying out an investigation into the heat given off when they add pieces of calcium to water. So both the students, Zara and Arun, they are performing the same investigation, same experiment, that is reacting calcium with water, and they are trying to see what is happening. Okay, so the one thing that they have kept constant is both are using 10 centimeter cube of water. So water taken by both is same, 10 centimeter cube, and they are adding pieces of calcium. Now they are adding pieces of calcium, and that is not given how much they are adding, but the table says that Zara's result is when Zara performs the experiment, the calcium that she has added to 10 centimeter cube of water is 1 gram, 2 gram, 3 gram, and 4 gram. See, this is given 1, 2, 3, and 4. Okay, calcium added, and start temperature is given as 19, 19, 19, 19, and the final temperature is given at 20, 21, 22, 23. This is Zara's table. Okay, it is given in the textbook, and the temperature rise, you can just find out the temperature rise from the table only. It will be 1, 2, 3, 4. Okay, so that is the table for Zara. Same way table for Arun is also given in your textbook. Now you have to compare these two tables and write the answer to these questions A, B, C, D. Now what is question number A? What trend is shown by both the set of results? Now both the set of results means the result of Zara as well as Arun. The trend is that the temperature is always increasing as the amount of calcium increases. So whether the experiment is performed by Zara or Arun, what common thing is seen is when they are increasing the amount of calcium from 1 to 2, 2 to 3, 3 to 4, okay, 1 gram is being increased. What is happening is the temperature rise is also increasing. Okay, so you can see that the temperature is rising from 21 to 22, 21 to 24, 21 to 25, that way. Okay, so there is always a rise in temperature. So the answer is for A, as calcium is increased. Okay, calcium is increased, the rise in temperature is also increased. Okay, so when the calcium was 1 gram, okay, the rise in temperature was 1 in the case of Zara, but when the calcium was 2 gram, the rise in temperature became 2. Okay, same way it was seen in the case of Arun. So this is one trend that you see. As you increase the amount of calcium, the rise in temperature is also increasing. B part of the question is predict what would happen if 5 gram of calcium was added. Now, in the table up to 4 gram they have given. So when 5 gram of calcium is taken, what is going to happen? Proportionally, the temperature will rise by 1 degree, isn't it? So for the 4 gram of calcium, the rising temperature was 4 degrees centigrade. So when you increase 1 more gram of calcium and make it 5, then the temperature rise will also increase by 1. From 4 it will become 5. So the temperature will increase by 5 degrees centigrade. This will be the answer. Okay. And D part of the question is, okay, now D is not given. Okay. Okay. D is construct a summary of the table. Now you can prepare the summary of the table, and I have prepared over here. So summary of the table is 1 calcium added 1 gram, 2 gram, 3 gram, 4 gram. Mean temperature change will be 1, 1.5, 3, and 4. Okay, and this is the table. See, read the question first. Construct a summary table to show the mean temperature change for each mass of calcium used. So mean of what? You know, mean of the two people that performing the experiment. So you have to see the mean of the rising temperature for both Zara and Arun. So if you see the last column of the tables, rising temperature, you have to take the mean of that. So the mean will be 1 for Zara for 1 gram. For 2 gram, it will be the mean of 2 and 1 will be 1.5. So this is the mean temperature. Okay. And third is 3, so the mean will be 3, and fourth column is 4, so it will be 4. Okay, so mean temperature column will be this 1, 1.5, 3, and 4. This is the mean of rising temperature of both Arun and Zara. Okay, that was question number D. Now coming to question number E, it says that Zara and Arun plot a graph of their results. So which variable of unit should be put along the horizontal axis? Okay, so always you have to put along the horizontal axis the one which you are keeping constant and one which you are increasing. Okay, variable, that is calcium. So horizontal axis you will put calcium. Okay, and which variable and unit should be put in the vertical axis? Vertical axis means y-axis. So on the y-axis, you will always have the dependent variable. So when you increase the calcium, what is happening to the temperature? That is dependent. So temperature, change in temperature or rise in temperature will be put on the y-axis. So basically on the x-axis, you will be taking the calcium, okay, in grams, and on the y-axis, you are going to take the rise in temperature, okay, delta degree centigrade rise in temperature, okay. So this is how we are going to plot the graph. And F is Zara and Arun carried out a third set of experiment using 20 centimeter cube of water instead of 10 centimeter. Could they use this result to add to the first two sets? Now, if now they are performing the experiment with 20 centimeter cube, so can the result be compared with this? So answer is no. Why? Because in this experiment, the comparison was possible because both of them performed the experiment with 10 centimeter cube, isn't it? But now when they are taking the water as 20 centimeter cube, this has been changed. The amount of water is changing. So you cannot say that the result will be same, or you can compare the result. Okay, so the answer is no, you cannot compare because the volume of water has now changed from 10 to 20 centimeter cube. So this was the exam style question of this particular chemical reaction chapter, and this chapter is over now. And now whatever worksheets I have, that we can discuss in the next video. But the chemical reaction chapter is over from my side in this 9 videos total. Okay, bye.